some more time on arrays because I think we have enough time in the semester. We can actually spend some more time on arrays. Yeah, let's go ahead and spend some more time on arrays. But this time, I want to use arrays to go back to one of the things that we have done before. I want to find prime numbers. In other words, I want to use an empty array. Let's say it's an array of 5 elements, and I want to initialize the array with the first 5 prime numbers. Okay, so let's go ahead and see how we can write an algorithm to do it. It's not only a review of arrays. It's also a good exercise to look into how do we design an algorithm. How do we put something together to begin with? So let's go ahead and take a look at that. Because I think it's probably better to slow down a little bit, take a look at, how do we write an algorithm to do a particular thing. So in this case, I will create a new folder. Okay, I will. Does not let me create a new folder. Today is the 14th. Uh-oh. That is not a good sign. Okay. Just took a lot longer than it should. Okay, so my assignment to myself is to write an algorithm to initialize an array with the first quote-unquote n prime numbers. Utilize the best algorithm to do this. In other words, I don't want to test whether 4 is a prime factor of some number anymore. I want to skip 4, I want to skip 6, I want to skip all the composite numbers. I only want to use prime numbers to test whether a number is a prime factor of another number. Okay? So this is what I want to do. Well, as usual, we want to do it by hand first. We want to see if we can capture the logic or have a systematic way of doing it manually before we try to write down the instructions of how to do it systematically. I will give you the first prime number. The first prime number is 2. Okay? That has to be given. What is the next available number? Not necessarily prime, but what is the next potential prime number? 3 is a potential prime number, right? So we move on to 3. Now, how do I know whether 3 is prime or not? We've got to test it. So in this case, if we test it with 2, if 3 is not wholly divisible by 2, so there are no more prime numbers to test. Can I stop there, or do I have to go and confirm that 3 divided by 3 has a remainder of 0? Remember the trick? 2 squared is already 4. So 4 is greater than 3. That means if 2 is not a prime factor of 3, I know for sure that 3 does not have any other prime factor than itself. Right? So 3 itself is prime. Then we move on to 4. 4 as the next potential number as a prime number. We divide 4 by 2. It has a remainder of 0. So we know that 4 is not prime. I don't even have to move on to 3 because all I need is to confirm that it has one factor other than itself, then it is not prime. Remember, this time I'm not factoring. This time I want to know whether it is a prime number or not. So 4 will not be added to the array. 3 will be added to the array. Next number is 5. Same thing. With 5, I first divide 5 by 2. It is not divisible. That's fine. I cannot get out of the loop just yet because 2 times 2 is 4. 4 is less than 5. I cannot yet confirm that 5 does not have any factors. Then I have to move on to 3, and then we say, what is 5 divided by 3? It's 1 with a remainder of 2. But then 3 times 3 is 9. 9 is greater than 5 already. I can exit the loop and conclude that 5 is a prime number. Is that okay? That's something that we have done before. And then we move on to 6. 6 is divisible by 2. We do not add it to the array. We move on to 7. With 7, I have to try it with 2. We have to try it with 3. But when I confirm that 3 is not a factor of 7, I can exit the loop because 3 times 3 is 9. 9 is greater than 7, which means 7 is a prime number. I add 7 to the prime number array, and then I move on to 8. Yep.
Okay, when you're dividing, like you divide it by 2, are you doing mod 2 to determine if it's mod 2 equals 0, then you know that is a prime number?
Correct. Yep. But I only want to add prime numbers to the array. In other words, the first thing I want to do is to initialize a bracket 0 to 2 because I have to start with one prime number. But the second one is going to be computed. This will be a bracket 1. This will also be computed. It is a bracket 2. This will be computed. It is a bracket 3, and so on. In other words, what I'm doing is in order to determine whether a number is prime to add it to the array, I can utilize the prime numbers that I have already found in the array. Okay, is that making any sense? Okay, so that's what we're going to do. And the question is, how do we write an algorithm to do it? First of all, do you think this algorithm involves a loop or not?
Yes.
Okay, looks like it is somewhat repetitive. So we'll say this is revision 1. The revision number is here so that we can refer to a particular revision number. When people have questions, they can say, okay, in revision 3, why are we doing this? Okay, so that's why we have the revision number. So in revision number 1, we say we have some kind of a loop here. Do we want this loop to be infinite?
No.
Okay, we want it to exit at some point. So when do we want it to exit?
When the array is full.
Okay, very good. When we have filled up the array with prime numbers. Very good. When we
a bracket
fill up the array with prime numbers. Okay, we can be vague. Okay, it doesn't have to be precise the first time. Okay, so now we move on to revision 2. In revision 2, we can start to introduce some variable names so that we don't have to say the array, this, that, and so on. So we can use more specific names. So in this case, we'll just say that let A be the array to contain prime numbers. Okay, so and loop exit when array A is filled with prime numbers. Still awfully vague, but slightly better than the previous version because now we have the notion of using an array, and the name of the array is A. Revision 3. Now, do we want to fill up the array in a random fashion?
No.
Or does it make more sense to fill it up sequentially?
It would be easier too.
Sequentially? Okay. So if you want to fill up something sequentially, you need an indexing variable to tell you, okay, which element in the array am I filling up this time? Does it make sense that you need some kind of an integer variable to say, okay, this time we are filling up this element of the array? Okay, so in that case, we'll let I be that particular variable. Let I be an integer variable that controls which element in the array we are dealing with. Okay. With this notation, is there a better way to say that exit when array A is filled with prime numbers? In other words, what is the proper range of values for I?
0 to 4.
0 to bar A bar minus 1. Okay, because we want the algorithm to be general enough that it will apply to all sizes of arrays. So we don't want to refer to 4. We want to say bar A bar. Okay? Bar A bar minus 1 being the last valid index. So now we can say when I is greater than or equal to bar A bar, it is time to get out. Does it make sense? How do I move on to the next one?
Wait a minute, wouldn't it be better to say bar A bar minus 1?
Bar A bar minus 1? But bar A bar minus 1 is the last valid index.
Okay.
Okay? When I is greater than or equal to bar A bar, then I know for sure I is no longer a good
up
index.
the whole thing and
Right.
you're an overflow.
Now, since we're doing it sequentially, that means how do we move on to the next element in the array per iteration?
The variable is adding one to itself.
Adding 1 to itself, so that means I gets I plus 1 per iteration. Okay, very good. So this is important because it is telling me that for each iteration, I'm bumping up the value of I by 1, which also means at some time, at some point, it will be bar A bar. Okay, very good. So we are working on this algorithm really step by step, slowly, but that's exactly what we should be doing because it's not easy to write an algorithm the first time. Revision 4. Revision 4 is asking, what else do we want to do inside the loop? What do you think we want to do in the loop? Yep. How about from the high level perspective? What are we doing per iteration of this loop here? We are trying to fill up the entire array with prime numbers. So for each iteration, what are we doing? To A bracket I. Exactly. Okay.
I was thinking you're going to be using an if statement to work your way through it.
Okay, what about this? What about I don't use any particular statement, I just say what I want to do without saying how I'm going to do it. Okay? How would you phrase what I want to do here? Find the next prime number and put it in A bracket I. Would that be okay? Does it make sense that we want to perform this operation even though we don't know necessarily how to do it yet?
How you're doing it. Yeah.
Okay, very good. So let's just kind of take a little pause here. Let's pause here and take a look. We have a loop. Per iteration, we want to find the next prime number, put it into A bracket I. Then we say, okay, add 1 to I so that in the next iteration, I'll be addressing the next element in the array. But we also want to make sure that we get out of the loop when I is greater than or equal to bar A bar. Does that make sense so far? Okay. So now we have revision 4, and we can move on to revision 5. Revision 5 is going to say, but how exactly are we going to do that? Okay, how are we going to find the prime number, the next prime number? Well, the first question is, what is the last prime number?
2.
Well,
is that right? That equals A.
2 is the last prime number in the first iteration of the loop. But in general, when you don't know how many times you have looped through this loop here, what is the best way to describe the previous prime number, or the prime number that you have found so far, the largest prime number you have found so far?
A bracket minus I.
A bracket, you got the right idea, just kind of reposition things a little bit. A bracket, I minus 1, close bracket, okay? So what we'll do is we'll say, we'll just comment here, okay? The last prime number is A bracket I minus 1. Is that making any sense? Because we are filling up the array sequentially. So that means by the time I want to fill up the element A bracket I minus 1 already has the largest prime number I have found so far. So the next number can start with exactly that.